y equals x squared minus 4x plus 1 on 0 is less than equal to x is less than equal to 4. So stop using interval notation. But you can just easily write interval 0 to 4 with brackets on it. Would mean the same thing as this does. So think about what the graph of this would look like. Could you describe it in a word? Parabola, yeah. Any holes?
Nope.
Any sharp turns?
Nope.
Wait, how do you know if there's holes?
Well, if it's a polynomial function, in general, it's going to be continuous everywhere. No junk, no messed up stuff. So it suffices to say, to clear off 1 and 2, you need to say it's a polynomial function. So, well, the other thing to check, though, is what? Endpoints. The question is, does f of a equal f of b? And on a parabola, it could. If you're turning around, you could have the same height at both. Let's just see if it works out for this. What's f of 0? 1. What's f of 4?
Not 1.
Sure.
Yeah, it is 1.
Is it?
Oh, it'd be 1.
Oh, it is. Done.
16 minus 16 is 0.
It'd be
1.
So table for us.
It's continuous and differentiable because it's a polynomial function.
C is at 2.
And really, I should say it's continuous and differentiable everywhere because it's a polynomial function. So it's certainly continuous and differentiable over a dinky little interval.
And then we have to figure out what C is,
Right?
right?
So how do we go about figuring out what C is for the punchline of the theorem?
Alright.
Set y prime equal to 0. Figure out what x value.
So guess who did that first? You did.
Well, what's y prime? 2x minus 4. You?
Do we have to do that?
Do what?
Like, figure out what f of c is? Like, we can't just say yes, it is. Like, we have to
Well, that's what they mean. If so, what is C?
Oh, I'm
Hey,
sorry.
that's- So we want to set that equal to 0. That's pretty easy to do. X has to be 2. By the way, is 2 on our interval?
Yes.
Darn well better, you got. I guess potentially you could get 2 values where x is, or f prime of x is 0.
Just pick those.
Pick the one that's on the interval. Or if they're both on the interval, super.
Super duper.
One more. One more of these things.
We just won't vote.
F of theta equals cosine of theta on pi over 4 to 3 pi over 4.
D&E.
QPL. Exactly. All right. We all know what the cosine graph looks like, right? It's a wave function. Any holes? Nope. Any points of discontinuity? No. I guess that is kind of saying the same thing. Any sharp turns? No. Only if Atari made the graph, then you'd have a lot of sharp turns. But we don't live in an Atari world anymore. Atari was a primitive game system. Pixelated graphics.
Yeah. CeeLo Green taught me about it.
What doesn't that guy know? All right. So I guess the next thing is, what's f of a? Cosine of pi over 4.
Square root of 2 over 2.
Square root over 2. I'm going to guess that 3 pi over 4 also gives you square root of 2 over 2, right?
Yeah. No.
No.
Negative.
No.
No, I see what you did there.
It's a negative square root of 2 over 2.
You're trying to trick us.
So this is
If this were sine theta, we'd be all right,
Yeah.
but not with cosine.
They'd be cruising.
So our answer would be no. Can't apply Rolle's theorem because
F of A doesn't equal.
yep, f of A doesn't equal f of B.
Hey, you were kind
Well,
of
thanks for coming after.
Well, I'm done teaching now.
Doesn't
No, really, I am. That's it. So we got assignment 22.
D&E.
Next.
I know. That's what I